We're going to share that. Okay, are we rolling? You see a weird drawing of a mouse and some weird structure like this? What is this? Does anyone know what this is? I don't even know what this is. I don't think this is the right talk. Well, hold on. Wait, yeah, it is. Okay. This image, believe it or not, is what got me on my journey to becoming a beekeeper. So I was going to school in upstate New York. I grew up as an artist, making portraits and landscapes, making a big mess with paint. And I got to a small kind of avant-garde school, and they said, "Oh, you don't have to please other people anymore. You can just do whatever you want." And I said, "Okay, great. I'm going to play with sticks and mud." And I got really interested in materials, where stuff came from, the ways that stuff was put together. Got me interested in where food was coming from, where everything was coming from, really. And I found a book, a really big book in the library called Permaculture Designer's Manual. It was by Bill Mollison, published in Australia in the 80s. And this is before permaculture became like a global hip trend like it is today. No one had checked out this book since the 80s. And I was just leafing through every page, and things would just jump out at me and had these like funny little pen and ink drawings. And so I came to this page with this drawing, and I'm like, what is going on? There's this mouse with this PVC pipe structure. Well, it turns out in Australia, out in the bush, people were building these structures out of PVC pipe, and field mice would go into these structures and store wild rices and wild grains. And the people who built these things say that as long as you leave about 20% of their harvest, the mice would just keep packing more and more into these structures. And so people were harvesting from the rodents, which most people see as pests. And this blew my mind. This completely shattered the screen that I was using to look at the world. And it really changed my life. This little tiny drawing of this mouse jumping out of the tube. Because like suddenly our pests can be our allies. We can work with them rather than trying to eradicate or sterilize or control everything around us. So let's take a different look, take a different approach, a different perspective of what is going on and how we can work with it. So this made me want to work in agriculture in some regards, because I just saw so much potential for change. There's so much room for creativity in this. And so it set me on a path. I was thinking about herding bison or sheep or harvesting cranberries or something. But pretty much I just met friends who knew beekeepers up in Vermont, and I went to work for a living. Let me see if I can advance this. Okay, there we go. Well, let's start at the beginning here. People and bees. Bees and people. Well, what's going on in this relationship? Well, it turns out that these creatures, these honeybees here, don't actually need to be saved. They're not in danger. I'm sorry to burst all your bubbles thinking that we're going to save the bees, but part of my job as an instructor at Queen School is to strip away your illusions. So honeybees are going to be just fine. They've been around for 60 or 70 million years. I think they have the ability to solve problems. On the other hand, people, this other side of the equation here is what I'm really worried about. The way I see it, it's not colony collapse disorder, not CCD. It's more like PCD, people collapse disorder. Think of how bees work in the ecosystem. Just the very means by how they eat, moving pollen from plant to plant, has been the catalyst for mutation, for diversity. It has created a vast, crazy amount of different insect-pollinated plants like that. Otherwise, everything would just be wind-pollinated, grasses, pine trees. That's all there would be. They have actually been like an incredible motivator for the diversity on the planet. Whereas humans, we're doing the complete opposite these days. We're going and paving everything over, or what farmland we do have left is just in sterilized row farms, all of just one monoculture growing. It almost looks suicidal, the way that we're approaching a landscape. I think we have a lot to learn from bees. And really, the idea that bees can help us, bees are a super organism. It's like really widely considered that they are more evolved than we are, being a super organism. I think that they share our interest in a diverse world and can help us to get there for our own survival. Well, I didn't know anything about this, and I still don't. I've been doing this 19 years. I know less now than when I started, but I've been doing it for a long time. So, well, I got my start actually going to work for a living. My friends knew Vermont beekeepers who had 1,000 hives. They said I could park my van out back to the honey house and just go to work getting stung for a living. And that is exactly what happened. My first day, I'm sure if you beekeepers out there remember the first time you have ever opened a hive. Well, I remember even before I got to that point, because the very first bee yard that I walked into, I either didn't smell right, or I wasn't moving correctly, or walking too heavy, and the bees just came at me. And I got stung 7 or 8 times in the neck, and they got caught in my hair. Even before I got the veil on, it was a mess. I was terrified. I hadn't been stung in years. I'd never seen a beehive before. I ran. I ran out of that bee yard. The bees chased me for a little bit, but then they settled down. I ran a couple 100 yards away. I sat down. I started catching my breath. I started picking the stingers out of my neck, and I looked up to this beautiful blue sky and this green field on this Vermont spring day, and I waited to see if I was going to die. I didn't die. Somehow I finished out that first day. For some reason, I came back to work the next day. And at that point, I was totally hooked on beekeeping. I realized it was the most difficult thing I had ever done up to that point in my life. And for that reason, I wanted to stick with it. And fast forward 19 years later, I'm still here, still doing it. And it's still very, very difficult. Like I said, I'm here to strip away your illusions. This is a lot of work all the time, but I wouldn't trade it for anything. Well, so over the course of those couple months in Vermont, I started learning about bee biology and how people ran their businesses and harvested honey. And I don't mean to open the story about getting stung to intimidate you newbies or those of you wannabes who don't have bees yet. These days, getting stung is my favorite part of beekeeping. We say if you don't get stung, the honey doesn't taste as sweet. But we know it has physical benefits. It's an immune system builder. It builds your white blood cell count. It increases your cortisone levels. It not only prevents, but reverses arthritis, multiple sclerosis. It's good with Lyme's disease, all these physical benefits from having a little bit of poison in your blood. But beyond the physical benefits, there are psychological benefits of the fact that I can get stung at any given moment out in the bee yard. Every time I open a hive, every time I'm going to inspect and I hang out with the bees for any reason, I have to be present. I have to be totally aware. I have to be totally focused on what I am doing. And I have to shut out the rest of the world. My whole life, people have been telling me to speed up, be more productive, go faster. The bees tell me to slow down. It's an incredible meditation every time I open a beehive. And it has to be a meditation. They're very good teachers, because if you are not turned on and in that moment, the bees are going to sting you. So it certainly takes some practice to have these Zen, very fluid, deliberate actions, but you'll get the hang of it for sure. So I don't ever wear any gear anymore. I get stung plenty. I got stung in the face today. Who else? Anybody out there get stung in the face? Where are my people? I guess most of the people are in winter right now, but it's okay. Well, that is a great gift that honeybees give us, the ability to have this meditation, this focus. And this focus can apply to anything in your life, in your world, any task you want to do. If you're able to calm your mind while you are getting stung, you can accomplish anything. Thank you, honeybees. Well, I was in Vermont for a couple months working for a 1,000 hive apiary. And, the boss said that the bees were sick. They were dying. It was hard to make ends meet. And I was going through frame after frame of plastic and these old, rotten, moldy boxes and sick and failing bees. I learned all about varroa mites, tracheal mites, and American foul brood, one thing after the next. So that was just hindering and really attacking these bees from all sides. Well, I was completely amazed by these bees, and I knew I was going to be like, I was able to do things differently. I wanted to empower the bees rather than trying to treat the problems, rather than trying to put a Band-Aid on the problem. I wanted to look a little bit lower, see what the real cause is. This hive died. Was it varroa mites, or like what's really under the surface? Or why were these bees out of balance and so stressed that this parasite was able to attack them? But I mean, I was 21 years old when I started, and I really had no idea what I was doing. I was just there to learn. It seemed that all my friends were moving to Brooklyn. I decided on a whim to move out to Montana. And I got a job with a beekeeper out of the phone book there, and I signed up for a 5,000 hive operation. We had 4 hives on a pallet. We put 400 hives on a semi-truck, and we shipped them to Central California and rented those hives out to almond growers, because those almond trees needed pollination. These almond groves, they couldn't have their own bees there because there was literally nothing else growing for miles. There was just almond trees, sand, and nutrient solution. Everything else was plowed or sprayed down to not compete for water in these groves. So these almond trees are 100% dependent on pollinators. So the honeybees, our most convenient movable pollinator, is carted in during the bloom. And when the almond bloom is done, they have to be carted out before they start to starve. Well, after almonds, we did a round of pollinating apples. And then we went back to Montana to pollinate cherry trees and a bunch of melons and vine crops. I learned that things you'd never even think of need bees for pollination. Carrots, not to grow this year's carrot, but to set seed. In order to grow carrot seed producers rent beehives. Onion seed producers rent beehives to do onion pollination, and they actually make onion honey. So all these things you would never think of, all are dependent on honeybees because they're the most convenient moving pollinator that we can drive around with. So honeybees seemed like this incredible, crucial niche to agriculture, but we're also we're so on the fringe. These beekeepers I was working for, they never missed a time to treat, a time to medicate for varroa mites, and a time to feed. Because if they missed that, the next time they went to visit their beehives, they might not have any bees left. It was that crucial that to keep these hives healthy. And you add the stress of being on the road, moving from one monoculture farm to the next. These bees were being poisoned from the pesticide applications and the fungicides, and being malnourished from only eating one kind of pollen again and again. And plus the stress of being shook on those trucks, it's really no secret why bees were dying. So these beekeepers wanted hives that were growing all the time. Because they were losing hives all the time, they wanted hives to constantly split, make a new hive, replace their dead one. So they wanted specific genetics that were turning all their food into more bees. And so that's basically an Italian-based bee, a bright-colored, broody bee that's just making more babies all the time. And beekeepers didn't mind supplemental feeding, things like that, as long as their bees were always growing. It's a very specific genotype of bee that the commercial guys want. And they're the first ones to admit that they've created a monster, that they are totally can't get off this treating wagon or this feeding wagon. It used to be easy for them. They used to stay at home and just make a honey crop and support their families. And now really no one does that anymore. Beekeepers of any scale put their hives on pallets and ship them to California, even from the East Coast, 4 or 5 days on the road. Go out there because the pay is that good for doing this migratory pollination gauntlet. It was crazy. It's a giant bug race. And commercial guys, the people who do this and move boxes for a living, they'll tell you they're some of the most miserable people that you'll meet. It's really, that's why I call myself a recovering commercial beekeeper. It's really their hard work and their innovation that is enabling our food supply in this country. The U.S. is already a net food importer. We don't even feed ourselves, but what vegetables we are producing for our own consumption are supported by these migratory pollinators who work so hard in order to keep their bees alive and meet their grower contracts and also support their families, meet their payroll. And it's just getting harder and harder for them all the time. So you can call it not even people collapse disorder, call it BCD, beekeeper collapse disorder. It's truly a labor of love. And they deserve a lot of respect for it. Well, I was out doing this migratory pollination on the West Coast for about 2 years when I got a call from my first boss in Vermont. He told me that his bees were dying. He was down to 500 hives from the normal 1,000 that he ran. And what he did was gather them all up by hand. He didn't have a forklift, so it was all just a hand labor loading a semi truck. He made some calls. He had some buddies down in South Carolina who would give him some spots to winter his bees down there rather than Vermont, to hopefully give them a milder winter, give them an earlier spring buildup so he could save his bees and save his bee business. He was tied up on the marketing end of things. He couldn't go down there to manage these bees. So he called me up and just begged me to come back and do whatever I could. And me, being totally naive at that point, said, sure, I'll see what I can do. There's no guarantees in the bee world, but I got a couple years now at this, and I'll give it a shot. And he stressed the fact that I was going to be all alone. Well, it was the spring of 2005 in March in the Tupelo swamps of South Carolina. The boss dropped me off. He gave me a map of where the bee yards were. He wished me well, and I started going through the hives that he had brought down from the north. I had to call him right away and tell him that another half of the bees had died. He barely had 200 hives alive from the normal 1,000 that he ran, and the ground was literally crawling with shriveled wing bees. They had a virus that were called deformed wing virus, where the bees have been chewed on by a mite. The varroa mite vectors this virus, and they're born without wings, and they can't fly, and they just crash. And it was a terrible sight where you could literally not take a step in these bee yards without stepping on this crawling, dying bee. And the brood looked terrible. The hives were going backwards. He had a white strip in every single one of these hives. It was called a checkmite strip. Checkmite is a coumaphos. Coumaphos is an organophosphate. It's a neurotoxin. It's really harsh, nasty stuff, this checkmite strip. I pulled up one of these strips out of the beehive, and there were varroa mites crawling up and down on the strip that was meant to kill them. The treatment had lost its efficacy. The mites had developed resistance to the checkmite. Checkmite replaced Apistan. Apistan was the first chemical treatment in the early 90s when varroa first came. And it worked for a couple years. It stopped working, then checkmite replaced it. And now I literally witnessed the failure of this mite treatment. And it looked really bleak. The hives were going backwards. I looked around. I was 24 years old at the time. I was responsible for millions of little lives. And I really had no idea what I was doing at all. I explained all this to the boss. And the next day, 12 liters of formic acid showed up on my doorstep. Formic acid is considered an organic treatment. It's an organic acid. And these days it is a gel pad, mite away. It's a registered product. It's a lot safer to handle. This is before it was registered, before it was a legal treatment. This was raw formic acid that showed up on my doorstep. And I had to figure out how to mix it down to the right solution. And I just got some butcher pads, dipped them in this acid solution. I held my breath as I laid them onto the tops of these beehives in a desperate act to try to kill varroa mites. We'll talk a lot in Queen School about IPM, integrated pest management, this pyramid of how your first go-to are your genetics, your mechanical controls, following the biology. Then you have more like softer treatments, sugar dusting, thymol, things like that. That last resort is your heavy artillery, your amitraz, or in this case, formic acid, because it was the last resort. We would have probably lost this entire operation, close to it. So that formic acid, even though it's considered organic and stuff, was very harsh on the bees. I saw that it killed a bunch of the young bees, a bunch of the open brood. But I put some sticky paper underneath some of these hives and came back the next day. I pulled out the sticky paper, and there were literally rows of varroa mites that had fallen from in between the combs. That mite kill was in the thousands. That formic acid worked. And as a last resort, if I ever had to, I would do it again. That's integrated pest management. And so it stabilized the bees, but that acid killed a bunch of the young brood. It killed a bunch of the queens. And even today, in safer gel pads at the right temperature, at the right dosage per population, it will be very harsh on the bees. But it stabilized them. Suddenly they weren't crashing from varroa anymore. We didn't have any queen bees ordered. Typically in commercial beekeeping, you order like hundreds of queens from a queen breeder. They come in little tiny cages, like so. They're already mated, and you can make a split with some brood, some honey, some worker bees. You can give them a mated queen in a cage. She's released in a day or so. She comes out, starts laying eggs, and the split starts to grow instantly. You can make hives really quickly that way. Well, trying to find any mated queens available in the spring is almost impossible. And the boss said I could just make splits with eggs, or make what we call a walk-away split. Strong hive, cut it in half, and whatever side is queenless will build a new queen in her absence. They'll pick several larvae, feed them extra royal jelly, and build several queen cells to replace their missing queen, as if they had swarmed. In a swarm, you know, the old queen leaves with half the bees. In her place, they raise several queen cells. Well, we didn't have any hives that were at that swarming, splitting level yet. They had been knocked back by the varroa mite infestation and then by the varroa mite treatment, that they were still just kind of limping along a little bit. And I wanted to speed up the process. So I did some reading. I hooked up with a couple of local beekeepers, and I taught myself how to graft. Grafting is the process of picking up a tiny larva from your breeder queen. You can't pick up eggs. They're way too fragile. You'll damage them trying to pick up an egg. But you can pick up a larva as young as possible with a tiny tool. And these days, most of us use these Chinese bamboo, handy dandy push button grafting tools. They cost all of $2.99 at any bee supply place. Problem was, here in 2005 in South Carolina, I didn't have the handy dandy $2.99 push button grafting tool. So I taught myself how to do it with a paper clip, which is like a torture device for these little bee larvae. I flattened down one end with a hammer to make it into a little spoon, and I was just doing everything wrong. I was rolling the larvae out of the cell. That was just mashing them up. I was using sunlight to see what I was doing, and the UV was just frying the larvae. It didn't go well at all for several of these grafts that I attempted. It really didn't go well until one thing happened. The tupelo trees bloomed. Famous Tupelo honey. That honey flow in spring of 2005 was so intense and so forgiving for me trying these new methods that my queen cells actually started to work. My grafts started to grow into cells. 10 days after the graft, I would take these cells, I would make a split. Each split would get a little cell. A day later, a virgin queen emerged from that queen cell. A week later, she went on a mating flight, came back, started laying eggs. And then the splits started to grow, and everything just started to grow. And I started grafting every day. I started having to split the splits I made a couple weeks ago, and I just kept splitting and kept grafting it day after day. I ran out of equipment. I had to build frames, put in foundation, and build boxes all night long just to use it up the next day. And weeks went by. This is full immersion, deep cover beekeeping. It's all I did. Until I looked at the calendar and realized it was the start of May. I got a count of the splits that I had made in all of these yards, and realized that the operation was back up to 1,000 hives. So this is the power of grafting. We went from 200 hives up to 1,000 hives in about 2 months, like that. Grafting isn't something that everyone has to learn, and we have been researching a lot of like simpler alternative methods, but grafting is all about the numbers. You can get the most cells per box, and you can just make queens the fastest through this power of grafting. And I was hooked. It made me a believer, being able to do this rapid recovery by being able to raise queen bees. So we shipped all those 1,000 hives back up to Vermont and upstate New York. We put them right on the dandelion honey flow. 2005 was a bumper year. Some of these early queens that I had raised went on to lead hives that made over 300 pounds of honey. It was a bumper honey crop. It was awesome. The boss told me I'd done such a good job. Since I was really making less than minimum wage anyway, he said, take 10 hives, take 10 of whatever you want. Pick out 10 hives of all this 1,000. Find yourself a bee yard. These will be your bees. This is a bonus for doing this rescue mission. Those 10 hives were the first bees that I got myself. And that spring in 2005 was the last time that they were ever treated. And so we're going on 16 years now, so 17 years now of no treatments. I say I treat them nice, and I feel confident about not treating because I know how to raise queens and I know I can rapidly make more bees if I ever had to. So that was the story of my first bees and how I got them. And I was kind of off and running from that point on with the creation of Anarchy Apiaries. Well, so I went back out west and I did another year of migratory pollination just to make some money like that, so I could buy myself some time, experiment with methods. And I wound up down in Florida after that, working for a beekeeper with 15,000 hives. Meanwhile, I had my own bee boxes, and I had taken my 10 hives out west and then down to Florida, and I turned my 10 hives into 150 three-frame nukes, little three-frame deep nukes. I had a standard Langstroth deep box, and I put 2 dividers in it, so I had 3 little baby hives, 3 framers in that box. And so I had built up to like a whole pickup load, 150 of these, like 50 boxes of my own bees. And I was like looking around, wondering what to do next. Suddenly, colony collapse disorder hits the newspapers. The whole country starts bugging out, like, literally. I realized I wanted to move back to the Northeast, where a lot of my friends were starting farms. They needed pollination support. And I wanted to see if I could cut it as a stationary northern beekeeper, breeding bees resistant to not only varroa mites, but for winter and for honey production and gentleness and all the things that we enjoy in our honeybees. And so I went back up there, put up some signs at health food stores and stuff, and suddenly I had 15 bee yards from scratch. A lot of people didn't even want rent honey or anything. So I put these bees on the dandelion honey flow. They took off. It was 2007 at this point, and I looked around and I didn't have another frame or another box or anything to put these growing hives into. I'd burned through all my pollination money at that point. I was broke again. So at that point, I think I really stumbled on the mission of Anarchy Apiaries. It's to bring the means of production back to the beekeeper. It's to make beekeeping a lot simpler, a lot more affordable, a lot more approachable than it's been for the last 160, 170 years since everything went Langstroth monopoly. So I had no choice but to start building some simpler hives I could build for cheap, and I did some research. I read about the Peace Corps in countries like Kenya and Ethiopia building what they called a Kenyan top bar hive, a trough that they would lay sticks like this on top of, and these would grow their combs off of the top bars. And this is me grafting into a top bar. And I realized, like, a top bar, you can do anything, any type of manipulation, the Langstroth you could do in these horizontal top bar hives. It's just that I was building a box for about $5 of rough cut lumber I got at the sawmill. I'll bring them a jar of honey. They'll give me like a bunch of extra wood and stuff. But really, these days, if you show me a dumpster, I can build you a couple of beehives out of the contents. Like, no problem. So I started building lots and lots of these top bar hives because my bees were swarming and I needed something to do with them. So honey would come later. I just wanted to be able to go into the hive, rate the health of their brood and stuff, and continue breeding the queens. So it's around this time I was building up to a couple hundred top bar hives. I was wondering, like, is this natural beekeeping? Does natural beekeeping even exist? It seems kind of like a paradox of like a beekeeping. Maybe if you have a hollow tree in your backyard, you're a natural beekeeper. But I knew I was different than like something like this, this kind of like intensive production oriented beekeeping. But this is where my roots are, and especially with permaculture, looking at inputs and outputs. I was wondering where I fit in somewhere with having a bee sanctuary versus full-on intensive commercial queen production. How big did I want to get? Well, I went out to Hawaii and I visited Kona Queens. At the time I visited them, they were the largest queen producers in the world. They produce around 300,000 queens a year, ship them all over the world. And these were just some of their cell-raising hives that they used to produce the queen cells. And this was absolutely amazing the way they had this set up. So they had a double nuke system. There was a queen laying in this double-stacked nucleus of a hive right here, 5 frames over 5 frames, and then another queen on this side, 5 frames over 5 frames, and then on top was a queen excluder that spanned both of their hives, so the queens couldn't get through the queen excluder to kill each other, which they would if they could. But a single box went above that queen excluder, and there was a pipe that went down every row of these cell raising hives, that pipe hooked up to a giant mechanical bellows that blew smoke down the length of this pipe. And with offshoots underneath each one of these little hives, that smoke would run the young bees. It drove the young nurse bees upwards through the queen excluder into this top box. And then as soon as they had enough bees bubbling out of the top box like that, and they were definitely queenless, they would slide in a piece of sheet metal and make that top box totally queenless for a couple hours. And sit like that, stressed out. You know, queen rearing is totally invasive, manipulative beekeeping, stressing out bees all as means to an end that they could graft 40 or 50 small queens, small queen cells into that cell raiser. So I mentioned talking about a walkaway split. You know, you can have a strong hive like this. You can just split it in half and you'll get one queen on the queenless side. Or you can take those same resources, do these manipulations where you remove the queen, remove all the eggs and all the larvae so they have no ability to raise their own queen. And then you can put a graft and raise 40 or 50 or more of these queens in the same amount of resources. So I was never going to get at this scale, but I was pretty inspired by the way they were doing things at Kona Queen. So, and really at this point, I've been raising queens for 19 years. I've really never done it the same way twice. You know, catch me this year, next year I'll be doing things totally different. But the point is I was trying lots of new things. I was raising lots of queen cells in the process. These aren't my queen cells. I wish they were. These are like excellent quality. These are some from Michael Palmer, our good buddy up in Vermont, who is just has super high standards for his beekeeping. He stays at home with his 1,500 hives in northern Vermont. And if one of his hives isn't making 200 pounds of honey, he'll go in and pinch the queen and replace her with hopefully superior genetics like that. It's his standard of excellence. You know, it might seem brutal and stuff, but he's a honey producer. This is what he wants out of his bees. And he's just kind of raised the bar of what beekeeping, how stock selection can go towards honey production. And also in his case, he has to winter his bees in 40 below zero year after year. And so he's a really good beekeeper at making this kind of stuff happening and with excellent quality. So I was raising lots of queen cells like this. And so I needed lots and lots of boxes. I was having trouble keeping up with my top bar hives, keeping the comb straight, and they were just swarming all over the place. I had 350 top bar hives at one point, and I had entire bee yards that swarmed before I even got around to them. So I started messing around with some different boxes and things like that. But I started taking this approach, you know, as like I say, I'm a treatment-free beekeeper, you know, but I run anarchy apiaries. Anarchy does not make rules for other beekeepers. You know, it's our basic tenet of that. We can all still get along. Michael Palmer treats his bees, you know, adamantly. He is like constantly monitoring for mites and keeping the mite loads down. But we're still really good buddies, and we respect each other because we make ends meet, and we both know what we can get away with. And the way that I get away with it, I know a lot of people don't want to treat. I think a lot of situations treating might be necessary, or at least an integrated pest management to know what you have, gather data, things like that. So through Queen School, raising queens, you know, there are like a real solid handful of treatment-free beekeepers around the country. They all raise their own queens. It's integral like that. They select their own genetics, they have methods that work for them, and they're also in good bee yards. All these things are really integral to making it work like that. And so we'll talk about all this stuff as we go forward and talking about queen rearing, because it's a rabbit hole. It's more and more intense. So this is one of my queens. She's still doing well. I saw her yesterday. Number 94. I think I'll talk briefly, just touch on these things as this first intro class about genetics and methodology and the environment. Genetics first, probably the least important, but still important. This is an instrumentally inseminated queen. We're going to have a guest speaker, Megan Mahoney, who does instrumental insemination, within a couple of weeks from now. This is one was inseminated by Dr. John Harbaugh, who was at the USDA Baton Rouge lab, the bee lab in Baton Rouge, Louisiana. He is one of the scientists who discovered a varroa-sensitive hygiene trait. We call it VSH. It's beyond just regular hygienic behavior. Regular hygienic behavior is bred just by freezing a patch of brood and then giving it back to the bees and seeing how long it takes them to remove that frozen brood. Varroa-sensitive hygiene is even more intense. You'll go into some brood and you have to uncap one cell at a time and count the reproductive varroa mites. And so by getting these low counts in breeding stock, they realized that what they were augmenting was a trait of a very good sense of smell. So the prodigy of this queen has a very good smell that they can smell an infested pupa that has a varroa mite on it. And so it's a couple different traits that they can smell the infestation, uncap the cell, and then remove the pupa that has the mite. So this is one of the most highly inheritable traits. Phoebe, come. That's my puppy. Phoebe, come. So this is a highly inheritable trait. And Dr. Harbaugh says that he'll sell you a breeder queen, but even if her daughters mate with zero VSH drones, they only have half of these alleles, that is still enough of the varroa-sensitive hygiene to keep the mites in the hive below a killing threshold with no treatments at all, just augmenting this one mechanism that the bees have. But this is just one mechanism, and we know that there are other mechanisms that bees use. There's grooming and biting behavior. They actually bite the mites off of each other and pick on their legs and things. There's shorter pupation cycles. There's an uncapping and recapping behavior. There's pheromones that aren't attracted to mites. There's a lot of different mechanisms. This is just one that we've found so far to be highly inheritable. And so a lot of us treatment-free beekeepers use these varroa-sensitive hygiene traits. And I have wild type lines that have different mechanisms, but I always keep a couple of these VSH queens around and raise a lot of daughters from them. So really excellent genetics. So I was making lots and lots of bees. I was having trouble with the horizontal top bars swarming all the time and keeping the comb straight. David Heath over in UK, he translated a book by Abbe Warre. He was a French beekeeper in the 1940s. He wrote a book called Beekeeping for All. It's a free download off of biobees.com, translated from the French. And it's just a beautiful book. It's really well written, nice philosophy about like bees know best. Well, us beekeepers really know nothing. We should let bees do what bees do. Bees are better beekeepers than humans are. And that really resonates today. But we hear about all these bee problems and stuff. We all want to save the bees, just leave them alone. The problem is today's world is not the same as 1940s France, Actually, the biggest problem, I think, is not just varroa, but the fact that bees aren't feeding themselves that much, even in a single season. If you have a first-year hive, chances are they're going to need supplementation to get through their first winter. It's very tough on them. And the only way you're going to know if your hive is starving or not, if you learn about their biology and go and inspect your hive and see what it's actually doing and learn about bees. You want to be a beekeeper? You want to be a better beekeeper? Learn about their biology. That's like as simple as it gets, but that involves opening your hive and not just leaving them alone like a hollow tree, like Warre used to do. It'd be great if that could be the case, but I'm a big advocate of going in, inspecting, splitting your hive, propagating your favorite genetics, and just learning about your bees and learning about your methods and what works for you. And so I changed the whole philosophy of Warre's approach. And also I changed the dimensions. I Americanized them a bit. I made them a lot simpler because the Warre hives are a little bit over-engineered, I thought. And to the point where people told me that I should stop calling them modified Warre hives and I should just call them comfort hives. And so it still seems pretentious to me to call them comfort hives. I call them little box hives and stuff. But it was inspired by the Warre book, which is an awesome read, and also by some other awesome beekeepers. Moses Quimby in the early 1800s was a box hive keeper. He ran 1,200 box hives long before Langstroth, and he adamantly refused to switch over to frames. Even before him, Edward Bevan in the UK experimented with box hives even before that. But this hive was first documented in 1682 by Sir George Wheeler in Greece. And this is probably the first documentation of an inspectable hive of just sticks being laid on top of a basket. And even Aristotle back in the time like noted a king bee. They were obviously inspecting hives thousands of years ago in that area. It was a misnomer of a king bee, but they obviously could recognize a different bee and were inspecting hives and learning about bees even back then. So I started just laying sticks on top of this box, and until I discovered, I was walking down the grocery store one day and I discovered this right here. This is the forefront of beekeeping technology. It is a barbecue skewer. It is a bamboo skewer. It's a 12-inch skewer. It lays on top of the 11 by 11-inch box. And once I figured this out, I realized I could build the whole hive without using a table saw. I still have all my fingers. You can just make this thing out of hand tools really simply. So I started making lots and lots of these beehives. And we started going through on a 3-week cycle, and I put a divider into these little hives. You see they sit on a milk crate. On top of it is an 18 by 18-inch ceramic tile. These are made out of pallet wood. I really make them out of anything that's not pressure treated. We put a divider in here. So there's a baby hive on this side and then that side and another box on that. So every stand you see has 4 little baby hives that we were using to raise a queen bee in. And after a couple rounds of breaking the brood cycle, removing the queen, breaking the brood cycle means that varroa mites also get a break in their reproductive cycle. So it slows down the varroa mite growth also. And the brood just really starts to clean up after a couple rounds, becomes virtually mite-free, and it becomes super brood, super well-nourished brood. And I realized this is the brood that I want to feed the next generation of queens. So I started putting this brood into cell raisers to raise next week's queen cells. I made a long trough box like this, and every 7 days we would put more capped brood in here and put a new graft on. And after a couple rounds of boosting these boxes, they started looking like this. If you want to raise really nice queens, you want more bees than fit into the box. And I got it down to a super simple system where I knew what I was doing every single day of the year. Every week we do the same thing. On Monday, we boost the cell raisers and graft. That's what I did today because I'm in queen season, endless summer down here in Florida. So today I boosted my cell raisers and I grafted. Tomorrow I'm going to catch queens down in Miami. And I'm going to bank brood from the clean brood from the baby nukes, the mating nukes. It's going to go get banked for next week's cell raisers, for next week's brood boost for the cell raisers. Wednesday, we'll finish catching all those bees, all the queens. And then Thursday, we'll place the ripe queen cells. Not from this Monday, but from last week's Monday. They'll be 10 days old when I put those cells in. That means they'll emerge in another day or two and then go out on mating flight a week later. And so this we repeat week after week. I have 3 different mating yards. And so 3 weeks go by the time I'm back to that first mating yard. It all runs like clockwork. So believe it or not, I need structure in my life. I need this kind of foundational base in order to keep me sane. And actually, it opens up endless possibilities for experimentation. Every week I get to try again. I get to see how good my graft is. This was a graft that was 40 for 40. Here, how good my graft is, how big the queens are. I can tweak something maybe on the cell raiser feed, or I can tweak some aspect of mating nuke boxes every week. So it's like having that foundation of knowing what I'm doing has enabled me to do just an endless experimentation like that. And it's also enabled me to open up the mating yards to visitors, who want to learn about queen rearing. Well, of course, all of us queen raisers, we want to raise the best queens possible. This is a purple-eyed stage queen pupa. She would have been a really good one. She's like a really good size. She would have been good if I hadn't ripped the cell open and stuff. But the smallest cells, that's the first stage of quality control. So we all want to raise the best queens and have the best hives that result from the best queens. So that first round of cells, not all of them make the cut. So some of these runty queen cells go into chocolate chip cookies. I'm seriously, I make these all the time, and I never find anyone to eat them with me. You come to queen school this summer, I'm going to make a batch of cookies for everyone. We'll see who eats them. Purple-eyed queen pupa. But you got to do something with the ones who don't make the cut. So this is an aerial shot of one of my mating yards where we had about 400 plus nukes. This is the Google map view from above. Every stand you see here has 4 nukes underneath it. And I actually designated each one of these circles to a different family line. And so the brood from that family line was going back to the cell raiser that raised the cells just for that family line. And you want to start talking about epigenetics and genomics, and it's a real rabbit hole of what we're talking about, the things that are going on in the very complex mating world of honeybees. And we'll get into it. We'll have a lot of late nights talking about bees. That's the whole idea. But like I said, I opened up the mating yard to visitors, and this was my buddy Aaron Jennings apiaries from Louisiana, who had 100 of his own hives. He had done some grafting before, and so he came out and did this 4-day catch, where we're boosting the cell raisers and grafting, then we're catching and banking brood for next week's cell raisers, catching more, and then putting the cells in. And I thought this was really the simplest that you could make queen rearing. I've been doing this for years now, and it seems so simple and effective. And I was producing thousands of queens. In 2020, I had a bumper year. I did 5,000 queens. It was crazy. So I thought I had this good honed in simple program. Aaron, at the end of 4 days, he looked at me and said, "This is way too much work. I'm just going to buy queens from you." I said, "Oh, geez, that really wasn't the intent. I really want to, launch a queen school so more people can produce their own local stock like this." And then I thought, this is too much work. Not everyone's crazy about working all the time like I am, And I thought, well, how do we make this simpler, Well, there's some beekeepers who just raise queen cells. They don't have that whole armada of mating nukes. And these are my friends, the mixes, who actually ship queen cells in the mail. So you don't need thousands of mating nukes like that. You just need a couple cell raisers, and you can still get the genetics out, and you can receive these queen cells the day they start to emerge, put them into splits and things like that. This is a real viable option for people who want to sell queens but don't have the critical mass with thousands of beehives. How do we make it even simpler than that? Well, this is a 2-day-old queen cell. You grafted, rather than letting the grafts go for 10 days, after 2 days after the graft, this larva is just floating in this pool of royal jelly and just very hardy at this stage in their life cycle. And you can ship these in the mail with no cover bees. You just have to keep them damp. You actually want the temperatures to cool down. It slows down their metabolism. And I've shipped them across the country like that to a beekeeper who makes a queenless split, puts in this queen cell. Those queenless bees accept that larva and they raise her to fruition. And then there's a genetic shift in the hive that way. You don't even have to write live bees on the envelope. Pretty cool from a genetic exchange. And we did a big research project looking at the quality of these things. It was awesome. Well, let's get even simpler. It turns out that bees do a pretty darn good job raising queens all by their lonesome. They've done it for millions of years, where us beekeepers think that we know better, we can make better bees. I've never been so sure of that. But I've also seen some really small emergency queens. This is an emergency situation that we remove the queen, the bees raise several of these queen cells. Ideally, the best one wins. I've seen small queens result, but I've also seen these giant, massive queens that supposedly have more ovarials and live a longer time when they're bigger. But so we've done some research that we'll go into in the future about these walkaway splits, honing down a really cool recipe. And it turns out that when you let these queens actually fight it out, that bees tend to let the best one win. They actually have a conscious quality control. They're tearing down inferior weight queen cells and leaving the best ones to come to fruition. And we've got some actual objective data to prove it. So this is one of our queen reports that we sent to NCSU, the North Carolina State University Queen and Disease Clinic. We call it the Queen Machine. This is David Tarpey's lab at NC State. And so you can send him a queen, and they will weigh all the body parts and measure all the body parts, and then they'll dissect the spermatheca. They'll tell you how many sperm are in the spermatheca, and then they will tell you, they'll actually put a stain on the sperm and tell you what percentage of that sperm is actually viable. So, and then they'll give that queen an A. or a B or a C, or they'll give a grade for the whole group that you send. So you can try different experiments or try different mating yards. Unfortunately, you don't get the queens back from that. But just as one of these data sets shows from these emergency bees choice queens, because the bees did the choosing, these weren't grafted, these were emergency queens that the bees raised all by their lonesome. It turns out that you can see that this is all the several thousand queens that the lab has ever been submitted to the lab over, I think they've been doing this about 7-8 years or so. And so these emergency bees choice queens were towards the high end of the spectrum, except for that one. I don't know what was up with that one. But it's and we have a bunch of these reports that were summarized in our SARE reports for this grant that you can see that, yeah, these emergency queens have the potential for a really high reproductive potential. So here she is. Today is her birthday. If you can see her, where is she? Right there. Today's her birthday, and she is caught in the act right now of slaughtering her sisters. I think she emerged from this cell right here. She's already killed that one, that one, that one. She's going to kill that one. May the best one win. This is a natural process like that. So often we let this happen with the idea that you have an excellent queen as the result. May the best one win. So I'm constantly doing hive design experiments, doing queen rearing experiments, trying to make this beekeeping thing simpler, because we got to turn it around, people. I mean, it's like the bees, the whole bees dying thing, stuff like that. I really, to me, the bees are just the vehicle. I'm worried about the people and how we can make a better, more robust, more diverse world, because that's what would be really better for the bees. And that's what they're telling us, you know. So I'm always trying lots of different things every year. I'm running bigger, these comfort hives, all different sizes and shapes, trying to make it cheap, simple, something that anyone can do in their backyard. And also we've combined it now with Queen School and make everyone their own micro breeder. Because you, even with one hive in your first year, you can make a simple walkaway split and you're suddenly a micro breeder. Simple selection of survival and vigor would turn this thing around. If we were all doing it with our few hives in the backyard, you know, it would put me out of the job and I'd be grateful. You know, my long-term goal is to have 5 hives, a fishing pole, a hammock, and a network of all of us micro breeders with our 5-10 hives that know, like in a good year, we have an extra split, an extra swarm to give to our neighbor, bring to our bee club. In a bad year, we lose half or more of our bees. We split our survivors and recover that way rather than buying bees from the South, California. It's like the way that we're going to work out of this bee problem. It's the only way that I see it. It's up to us, the micro breeders. So we're all part of it together. I double up my skewers these days, make them a little bit stronger like that. You can even use just like a piece of bamboo. Don't buy anything. That's my mantra, right? If there's one thing to take away. And I love the bees that I have. I really see them as kind of wild, you know. These are like tree stumps, you know. They swarm out to the woods. For me, that's a success story. It's a sign of their vitality. They come back, you know. It's really a dialogue I'm having with all the bees in my community. And we can go forward from there, you know, not having to buy in more genetics or buy bees or depend on any outside influences. This is permaculture. We look at inputs and outputs in the apiary. Of course, you can get free bees, talk about bait hives and things like that. We'll go over all of this cool stuff. And you can get awesome bees out of the wall. Better than any bees you could buy anywhere are the ones that are surviving locally for you. So as a micro breeder, you know, sourcing some bees like that, putting up bait hives, you will get these special genetics that you can't purchase out of the American Bee Journal stuff. It's something, it's an opportunity that all of us have, seeking out these wild survivor hives and propagating them. All right, well, I'll start to wrap this up. I'm about out of time, I think. So where's this thing going? You know, us beekeepers, we're on the fringe. We really are. We're like the freaks of agriculture. We're crucial to agriculture, but we're really on the outskirts because we appreciate wilderness. We appreciate the wild. We appreciate these set aside bits of land, these meadows, weeds, wild plants that have seemingly no other purpose. Us beekeepers understand that they're vital, and wilderness is our salvation. That was like a Thoreau thing. We have to retain that. We're like carrying this torch to pass this on. That like, hey, why not keep this spot wild just for its own sake? Well, remember the first time you opened up a beehive. It's a moment that I'll never forget. It's something that we'll never forget. You're experiencing some of that wildness because bees are still a wild creature. We've tried to domesticate them, but they're not like cows. They're quickly going that route, though, being hooked on antibiotics, being hooked on supplemental feeding. And bees don't have to go that route. They're still resilient. They're still wild. This is something that we can retain and appreciate and study. So that first time that you ever opened a beehive, realize that that is a gift you can give to someone else. You can show them bees. The next time you like read a bee magazine or go to your bee yard or go to a bee club or open up a hive, consider bringing along a young person around for the ride, because the first time that they experience bees is going to be a day that they also never forget. And we all have to start doing this, and stick together like bees, give up our egos a little bit and just share in this like wonderful cycle of nature. Because if we don't, we're all going to end up as the lone beekeepers out in the crowds wherever we go. So, and some selections for my propolised mouse collection. It's very choice. I'll have a display case at Queen School this summer, I'm sure. But that is it for my spiel. That is my BB dog on display. And I think I can probably field a couple questions, and we're going to talk about what we're going to do this summer and what we have coming up online in the next couple of weeks. And thank you all for coming out. It's awesome that you're all here, and good luck in your beekeeping.
Thank you, Yay. Sam. So before we get into questions, we have just a quick eval that will help us to keep bringing these things to you free. So I just dropped this in the chat. It's a Google form. Just take 2 minutes and fill that out for us, please. It just helps us know what this experience was like for you, what you learned, what you might use in your own bee yards, and that's also going to help our funder, who is Northeast Sustainable Agriculture Research and Education, continue to sponsor us in doing these things, because we got to write lots of fun reports about all the stuff we're doing. So yeah, take 2 minutes and do that. If you need to get up and stretch, take a minute and do that. We will come back together at 8:13. So if you need to step away from the screen, refill some water, do that. And we'll take a short break and reconvene together to take some of the questions that y'all put in the chat. If you have questions right now and you have a burning desire to share them, you can drop those in this chat, and then we'll have those accessible as well. But for right now, take a minute, fill out this form.
Also, if you need more than 5 minutes to fill it out, feel free to take that time afterward, after we finish, and submit it. But please just be sure that you do fill it out. It's really important for us to have that data.
If you're still making your way back to the computer, that's okay. We are going to start with some questions. So you want to read this first one, BB?
Sure. All right. So the first question was, is there a manageable or moderate path for backyard queen rearing? It seems once you get on the treadmill, you're always juggling frames into and out of the mating nooks.
Yep. Just sign your life away. It's really as much work as you want to make it. Queen rearing, I mean, you could have one hive that you never open. It swarms. Hey, you're raising queens. Because they swarm, they raise a new queen. You're raising queens in your backyard. Or you can go in and graft like 50 cells into that same hive. It's really your world or something. But bees want to grow. They want to split every year. They want to raise queens, so they're going to do it with or without you. And we can help the process, especially if we're looking to augment traits like mite resistance or winter survival, or being more self-reliant in our beekeeping practice. We can speed up that process, and that's one of the coolest things about queen rearing. You can get a bunch of bees, plan on killing some of them off, but if you raise from your best survivors, you'll see instant improvement in the first generation. But yeah, this can be a whole ton of work. That's like, there's no getting around it. You know, having equipment is like one of the hardest things, having enough spare boxes. That's why we've tried to do like simplest boxes possible. And these are the boxes that we're going to mess around. We're going to play with comfort hives all summer in Queen School, because you can build one for about 80, 90 cents of lumber. It's you can make lots and lots of them, and you don't have frames. You just have skewers. You get them at the grocery store. So we tried to simplify the things and make it less work and stuff. We're going to go into like the real intensive practices like grafting and stuff like that. But we're also going to cover walk-away splits and stuff that anyone can do, and it just takes a second. You can instantly make a split like that, come back in a month or next year or, next lifetime.
Awesome. Thanks, Sam. Next question is about yellow jackets. Any suggestions?
Ouch. It seems to be really bad in dry years, So, the answer is the same for whether it's yellow jackets or ants or hive beetles. It's all about like strong bees. Like strong bees are, I think in the winter, reducing entrances is a good deal. There is that slight temperature window where the bees aren't flying. They're in cluster and won't break cluster. The yellow jackets are flying and they're picking off the cluster. Really, the ultimate answer is keep more than one hive, because there's always going to be losses. If you've never had a loss, you're gonna sooner or later, It's like once you really think you know what you're doing, that's when the bees really start to go downhill.
They wake you up.
That's the best answer I got for yellow jackets. Yeah.
Sam, thoughts on how to manage queen production when you are getting decimated by commercial beekeepers taking your territory? Someone's saying that when large commercial beekeepers come in the Northern California area, that it's really difficult for them to
those guys really saturate. Move. But I know that's not the easiest answer. Move somewhere where there's water, but I've worked a lot in California, Northern California. It's like you can just every stone's throw, there's like a semi-load of bees. They're just everywhere. And, like I mentioned, those genetics are all about almond pollination or like maximum honey production of these huge clusters of bees. It's really, really different genetics from having a couple hives in your backyard you want to keep alive with minimum inputs. So if your queens are crossing with those drones, especially if you're close to commercial apiaries, you're getting flooded out by those drones. There are a couple tricks for mating control. One, you can use like II queens, which is like a really difficult process to learn. There are a couple tricks that you can actually freeze. You can cool down your nukes so your queens are gonna, you let them out of this cold room a half hour before dark. And if you can train your drones to also fly a half hour before dark by having a drone excluder on them, you could have a perfect mating just a half hour before dark when all the other drones in the area have stopped flying. It's just developed by a beekeeper in Australia named Joe Horner. It's called a controlled flight time mating of honeybees. So a controlled flight time, whereas your nukes are in a cold room until a half hour before dark, and your drone producers are also excluded by a drone excluder till a half hour before dark. He's been doing this for decades and has pure mating that way without learning how to do instrumental insemination. But other than that, go up a mountain, find an island, things like that. It's what a lot of the real breeders, if you're trying to avoid those genetics, that's kind of like the only thing, only way to get around it. So.
Cool, thank you. The next question is about record keeping. What is useful data to record when doing a hive inspection? How do you track results for queen production, etc.? Any advice on that?
That's a good question. Really good. Like everyone's different. I keep like experiment notebooks of like broader experiments that I'm doing and the results. So I started finding myself, I was repeating things that I tried 10 years ago. And I'm like, oh, wait a second, this didn't work 10 years ago and it's not working again now. That was stupid. But I have a marker or a paint pen, and on tops of the tiles, I have the mating history through the whole season of the mating yard. So if we stole a mated queen, it's a -Q. If it was a miss, it gets a null set sign. If it's a virgin queen or a laying worker, I can look back. We're on a 3-week cycle. So we're into a mating nuke every 3 weeks. We drop in a ripe queen cell. 3 weeks later, she should if the new queen is successful, she should have her own capped brood, and the cycle repeats. So I can look over the history of that mating nuke over the last 12 weeks or more. And I see, if it's a divided box, it's like miss, miss, miss over the last 3 catches. I'll look at the divider, and often the bees are getting around the divider and killing the other queen or things like that. So like a lot of notes is really going to help with, just honing in your methods, tightening up your equipment, all that kind of stuff. The more notes, probably the better, but I'm pretty old school. I have a pen and paper. I write a marker on the lid of the hive. And I've been able to track families. The queens that I keep, I tend to mark as potential breeders. And I've had some of them go for 5 years or something, just because I know it's them because they are marked. And I put them in out yards. And I really only have out yards to test genetics, to test different family lines, see their temperament, their mite resistance, their ability to winter, stuff like that. And I'll take notes for all of those potential breeders, if they make honey or not, the size of their cluster coming out into spring and things like that. So there's multiple tiers for every aspect, and all depends on kind of what your interests are in raising queens or in your beekeeping. So it's a rabbit hole.
Go ahead.
Sweet. Thanks, Sam. Next question is understanding more about the 2.0 design and why you switched from single boxes to double boxes.
I still do a little bit of everything. You all are going to love the 3.0. It's awesome. 3 boxes tall. The longer, the taller the hive is, the more side attachments you get, a little bit slower that it is, but it's still faster than working Langstroth hives and prying apart the frames and stuff, especially when they're all glued together with propolis. And, my hive tool is just like a butter knife, so 90% of your attachments are going to be reachable with that butter knife. You can always unstack the other boxes, cut side attachments and things like that. So I do a little bit of everything with these, the comfort hives. For years, I was stapling in a bar rest, and every single box had a set of skewers, and I would slice them apart with a long bread knife. Warwick talks about using a wire to slice them apart. That never seemed to work for me. It hurt my hands. But a long bread knife works good slicing them apart. But you slice through a bee here, there. It makes the hive angry and stuff. But it worked to get them apart, and I could bust up all these little baby combs like that, all into nuke boxes and things. But it's still a little faster for me to just have longer combs and a set of skewers on the very top. And now I don't even use bar rests. I'm just setting the skewers on top of this 11 by 11 inch box. 12-inch skewer sits on that. I can get into those hives, in and out of them faster. And basically my mating nuke will be 3 boxes of tall, 18 inches tall, but only have maybe 2 combs in it. So it's the same amount of bees as a mating nuke, but they have all that empty space so they can grow up after I'm done as a mating nuke. So it's a different approach, but with the same style of boxes, but with longer combs rather than short ones. Our friend Tuckapee likes the shorter combs, and she'll slice them all apart with a knife and into the baby nukes. But it's basically, I came up with this stuff, but you all can run with it and see what works for you in your beekeeping. I'm liking the longer combs because the bigger hives, they need a lot less feeding. The smaller the hive you do, the more coddling it needs. It's either swarming or starving. There's very little in between stuff. So I'm running these quite a bit bigger these days, because one year, I tell you, I hit 10,000 pounds of sugar that I was buying just to feed my baby bees like that. I wasn't stealing the honey from the big ones and replacing it with sugar. No, this is just to grow the bee nursery, the babies. They were starving. 10,000 pounds of sugar. I got into bees through natural farming and permaculture. How did it come to this? Why am I buying thousands of pounds of sugar? But bigger hives do better at managing themselves and feeding themselves a bit. But so we do a little bit of everything is the answer.
I'm not answering that.
Awesome. All right. People want to know how the walkaway split queens from the study are going so far for this winter.
They're still up there.
survival.
I haven't been up there in quite a while. I mean, they do need feed, especially if you do 2 rounds of walkaways in a single northern season. Like swarm season starts revving up in like early May. You know, I'll skill queens, make walkaway splits, and then once she's mated, you can do another round. You know, about 5 weeks later. Or so, 4 to 5 weeks later, you can steal the queen, or you can let them recover even more and steal the queen 7, 8 weeks later. But if you do 2 rounds of complete full brood breaks, I tell you, by the end of summer, they're almost virtually mite free from the shorter brood rearing. Also knocks down the mites, but they generally do need a lot of feed like that because they're pretty small for honey gathering and things like that. But as long as you're feeding them, these are clean. You know, they winter fine with less stress in smaller clusters, and they consume less if they are really clean. And not only mites, but also the associated viruses like that. So it's one way to get them really stable and ready for winters. You got to have them clean way before they even think about raising winter bees, because it all accumulates over the season. Whereas with no brood breaks, your virus levels are just growing and growing. You knock down your mites, but the viruses are still there. But so in terms of like the walkaway queens, I swear by them. I think they're great. I used to cut out the cells and disperse them, each cell that they make in a single hive. You split the hive, you come back in 10 days and you re-split. And that I found that the queens can be pretty poor quality. You'll get a couple really good ones, 2 or 3 really excellent, huge queens. But a lot of the smaller cells will have smaller queens result, and they get superseded or don't do as well. So these days I tend to just make the split and come back in a month, and I let like however many cells they want to raise, I let them fight it out, or like the way that bees do it, you know, high drama in the beehive. But I still graft. But selling queens still like funds my operation and stuff like that. But I'm trying to put myself out of a job, like I said. So I still do a lot of grafting and from like select genetics, and I'm still tracking lots of these families I'm grafting from. But my heart is pretty much in the walkaway queens because they're so much fun, and I just like letting go control. Everything gets a little tedious sometimes with the regimented queen calendar, and I just know that bees can do as good or better a job than I could ever do. So,
Thanks, Sam.
Mm-hmm.
So just shifting gear a little bit, I want to acknowledge that folks are asking about the design, and I put the link to our How to Raise Sustainable Queens document in the chat, and that breaks down the design. It's got a great photo. It's got measurements there as well. And then Sam put in the Comfort Hive survival guide, or the beekeeping survival guide as well. So that's linked in the chat.
I should tell you all how to fold it too.
There it is.
So this is a free download. You know, this is hot off the presses, 2022, the Beekeeping Survival Guide. This is actually the 10-year anniversary of me doing this little tiny mini zine. So you download, printed it out as one page. There is some assembly required. So what you got to do is actually cut it like so. You got to cut right there. And then you'll have to figure out how to fold it to make it into this little punky mini zine. Good luck. Make copies. Spread it amongst your friends and swarm the state. This is your party favor.
Great. Thanks, Sam. All right, there are a couple other logistical questions, but we are going to have to pause here so we can respect everyone's time. We are at that 90-minute mark. We are going to have more of these, so there will be 3 more opportunities for you to hear from different queen producers, different beekeepers from across the U.S. The next one is actually going to be Bee and I. We're going to give you a presentation about some of the research that we did, talk about the 48-hour queen cells, the walkaway splits, the results of that research, and what we learned about the best ways to raise queens. We'll also talk more about the comfort hives. We can get into the nitty-gritty of questions about how to get comb to stay on skewers and how to build the very best bottom boards possible for where you are. That is going to be on February 21st at 7 p.m. So save the date. If you already signed up for today's class, you don't have to do anything. We're going to send you an email a few days before the 21st and say, hey, class is at 7. And here's the link to Zoom. So there's nothing you have to do. Also, if you are here tonight and you want a recording of this, we're going to make sure you get that with the Q&A as well as the presentation. That'll be accessible to everybody via a link who attended tonight and folks who were signed up and weren't able to attend. So if you've got a buddy that didn't catch this, they'll be able to get that. That's going to be true for every single one of these. We're going to record them. We're going to share them with y'all as long as you're registered. And then we are going to get slowly into talking about hands-on Queen School, which is going to be this summer, once a month here in Western Mass. So again, if you're on this list, you're on all the lists, you'll know about everything that's happening first, and you'll be able to participate. So thanks again for being here tonight. We're really stoked to be doing this. We are definitely building bridges as we are walking on them. So we appreciate your patience with our technology skills, as well as, you know, just figuring out what works and doing that. Thanks again, and we'll see you in a month.
Thanks, everybody.
Thanks,
Thanks,
you in
Sam.
February.
Bye.
Bye.